Okay, so different orders. First, we will discuss about the zero order reaction. Zero order reaction. What is zero order reaction? Meera and Upsana?
Ma'am, their order is zero.
Yes.
The order is zero.
Yes. And what about the rate? Will you,
Rate is independent of the reaction.
yes. Rate
Rate,
is independent of the concentration of reactants, right?
yes.
Okay. So zero order reaction means the rate of reaction is directly proportional to zeroth power of the concentration, right? Concentration, zeroth power. Or you can write it down, K is equals to A naught, it's A concentration upon T. This will be the formula for rate constant for zero order reaction. And what is A naught here? So A naught is initial concentration, right? A naught is your initial concentration of reactant, and your A is the concentration of reactant at time t. At time t. Okay. And in zero order reaction, the rate doesn't depend upon the concentration of reactants. Okay. So when you plot the graph between, see, when you plot the graph of concentration versus time, what you will get? You will get a straight line with a slope of, see, this type of graph you will get. So this is basically concentration versus time graph. Okay, you will just, this type of graph you will observe. Okay, and here the slope is equals to minus k. Okay, in the zero order reaction, the slope is always equals to minus k. Just remember that. Okay, so this is a variation in the concentration versus time. Okay, and what will be the example of a zero order reaction? Anyone?
Decomposition of gaseous ammonia.
Any other example? Any other one more example is there? Photochemical reaction with photochemical reaction also follow a zero order reaction. Okay, photochemical reaction. Okay, so this was the zero order reaction. What you have to remember in this? Just remember that the order is zero and the formula for A, right? It is the initial concentration of reactant minus final upon T, right? And the graph is, you get the slope to be minus K. Okay, next one. Your first order reaction. First order reaction. Okay, so in the first order reaction, the rate is directly proportional to the concentration of reactant. That is, okay, rate is directly proportional to concentration. Okay, and formula, just remember that K equals to 2.303 upon T log initial concentration upon final. Okay, just remember this formula. for first order reaction. Okay. So when you draw a plot between log A naught upon A versus time, this type of graph you will observe. So on the x-axis, we are taking time, and on the y-axis, we are taking log A naught upon A. Okay, so you will get a straight line. Okay, the first order reaction, will observe a straight line, and when we talk about slope will be equals to A upon 2.303. Okay, remember that. And what are the examples of these? So examples of first order reaction will be, you can say the disintegration. Radioactive disintegration is the best example of this first order reaction. Okay, radioactive disintegration type of reaction follows first order kinetics. So just in this first order, just remember this rate law and your graph, rate equation and your graph. Next is your, you will tell me what is pseudo first order reaction. Pseudo first order reaction. Why it is known as pseudo?
Reactions that appear to be higher order, but then it's actually first order.
Yes. Okay. Now see, pseudo means false, right? The name suggests that it is false. So the reaction which is not truly first order, right? But under certain conditions, it becomes first order reaction. That's why it is known as pseudo first order reaction. Okay. And in the pseudo first order reaction, the concentration of reactant which is present in excess doesn't affect the rate of reaction. Okay, so we didn't consider it in a rate equation. Okay, I repeat, if the concentration of reactant is present in excess amount, right? So it doesn't affect the rate of reaction. Hence, we didn't consider it in a rate equation. For example, if in bimolecular, in bimolecular reaction, okay, one of the reactant is present in excess amount, right? In excess amount, the reaction becomes first order. First order. Okay. For example, hydrolysis of ester. So best example of pseudo first order reaction. Hydrolysis of ester. So when ester undergoes hydrolysis, for example, let's take a, it's an ester, right? So the hydrolysis and water is in excess amount. Okay. And what will you get? You will get, when the hydrolysis of ester occurs, you will get carboxylic acid and alcohol. So this is carboxylic acid and alcohol you will get. So what will be the rate? Rate is only dependent on this R-C double OR ester group, not on the water, because it is in excess amount. We will not consider it in a rate equation. Okay, so the rate is dependent on only this ester, this reactant, not on the water. That's why it is known as pseudo first order reaction.
Yes, ma'am.
Yes, ma'am.
Okay, we can see another example. Just say first order reaction. It's important. Okay, let's do a question. For example, a reaction is there given in which A plus B it forms P. Okay, it is found to be following the rate equation. Rate equation R equals to K into A. Okay, determine rate equation. If B is taken in axis. Okay, tell me. Let's determine the rate equation. What will be the rate equation here? And what will be the order? Sorry.
Order will be 1, the first
Yes,
order
good.
reaction.
Good. Okay. And see, because I just told you that if some reactant is in excess amount, then we will not consider that in a rate equation, right? So what will be the rate equation? Because B is present in excess amount, right? So we will not consider B in the rate equation. So rate equation will be K into concentration of A only. Okay. We will not consider B because it is in excess amount and order will be here 1. So that's the pseudo first order reaction. Okay.
Yes, ma'am.
Yes.
This is your half-life of the reaction. And yeah, this is very important. From here, the question came in your JEE mains exam. Yeah, so just memorize all the formula over here and practice more questions based on that. So what is half-life? It is defined as, and it is denoted by, just a second. Okay. Half-life is denoted by T half, right? What is T half? So the time taken for half of the reactant to react, right? Or the time taken for half of the reaction to get completed, can say is known as half life of the reaction. So what will be the definition? I'm sorry, I'm not well today. The time taken for half of the reactant to react, or you can say the time taken for half of the reaction get completed. Right? Or in other words, you can say the time in which concentration of reactant is reduced to half, is reduced to half of its original volume, of its original value is called its half-life, half-life of the reaction. Okay, So that's called the half-life of a reaction. Now let's see one by one what will be the half-life of zero order reaction, first order reaction. Okay, so for a zero order reaction, half-life, we know that rate constant K is equals to initial minus this upon T, right? And we suppose that at T becomes half, right? And concentration, it becomes half, right? At T half, right? When the T is equals to T half, what happens? The concentration also becomes half. So just substitute this value in the rate equation, in this equation. What will you get? K will be equals to A naught minus half of A naught upon T half, because T is equals to T half, half-life. So from here, okay, when you calculate this, you will get T half value to be A naught minus, and from here you will get 2K. So this is the formula for T half of zero order reaction. Okay, just remember that T half is equals to concentration of A naught upon 2K, 2 into rate constant. Okay, let's see for first order reaction. For first order reaction, what will be it? On that, for first order reaction, K is equals to 2.303 upon T into log A naught concentration upon A. Similarly, you know that at T equals to T half, what will be the K value? K value will be 2.303 upon T half into log, and this A will become half of A naught. This is A naught upon 2, right? So just substitute this value, A naught upon 2. Okay. So when you calculate this, you will get the T half value to be 0.693 upon K. So this is for first order reaction. Okay.
Yes, ma'am.
Okay, good. Written?
Yes, ma'am.
Yes, ma'am.
Okay, now let's see. So the half-life of the reaction. You just, okay, revise all the formula. This is very, very important. All the formula for half-life and rate constant. And yeah, see, types on, this is Arrhenius equation. But before that, do you know what is exothermic and endothermic reaction? On the basis of energy, there are two types of reaction, endothermic and exothermic. Now, what are endothermic reaction and what are exothermic reaction? Because you have done with class 12th, right? We are revising the concept. Don't know? Okay, so endothermic, like, types of reactions on the basis of concept of energy. are they? Exothermic and endothermic. Exothermic reaction and endothermic reaction. Okay, now see exothermic reaction. It is a reaction in which energy is evolved along with the product, right? Exo. Exo means energy is being evolved. Energy evolved, right, along with the product. And what is endothermic reaction? It is a reaction in which energy is supplied to the reactant from the surroundings for the reaction, right? So these are exothermic and endothermic type of reaction. Now, let's see Arrhenius equation. Again, it is very important, Arrhenius equation. So do you know how Arrhenius equation is expressed? So see, so Arrhenius equation it is expressed as A equals to A e to the power minus EA upon RT. Again, it is very important equation. Okay, and where A is constant, right? And it is also known as free exponential factor, and it is also known as frequency factor. Frequency factor. Okay. And EA is your activation energy. Activation energy. And R is your gas constant and T is your temperature, right? So basically, it denotes the frequency of binary collision of reactant molecules, right? Per second per liter. Write it down. This equation, it denotes binary collisions of reactant molecules per second per liter. Okay. And here EA is your activation energy. Right? And R is your gas constant. Is your temperature, which is in Kelvin. Right? And you all know that K is your rate constant. It is a rate constant of reaction. Now let's see integration form of this equation. So if we take log on both sides of the equation, the reaction, what will happen? Taking logs. Both sides will happen is equals to minus EA. When you take log, it will be plus, it will become log 10 A. Okay. Now see if K1 and K2, these are the rate constant which are measured at two temperatures, like T1 and at T2. If K1 and K2 are the rate constant measured at two temperatures, T1 and T2 respectively. Okay, then what will be the formula? So it will be K2 upon K1 is equals to EA upon 2.303 R 1 upon T1 minus 1 upon T2. You will get this formula. Mark it important. It's important one. Okay, we will use in the numerical by solving for solving activation energy, or they can ask you to solve for rate constant, or sometimes they ask temperature also. Okay, just write it down. Write down the Arrhenius equation. Arrhenius equation at two different temperature. This is important. The last equation. And this formula can also written as log K2 upon K1 equals to A upon 2.303 R into T2 minus T1 upon T1 into T2. Okay.
Done, ma'am.
Okay. Okay, I'll give you a question based on that. Write down the question. Okay, write down the question. The rate of chemical reaction doubles on an increase of 10 Kelvin in absolute temperature from 298 Kelvin. Okay, now calculate activation energy for the reaction. Just calculate it using that formula and tell me the answer. Just quick. I need a quick response. The rate of chemical reaction when it doubles on an increase of 10 Kelvin in absolute temperature from 298 Kelvin, then calculate the activation energy for the reaction. Very simple question it is. You can use the calculator. Done? Okay, see what I given here. So T1 is given 298 Kelvin, right? T2 is, yeah, see, here it's given that an increase of 10 Kelvin in absolute temperature from 298. So 298 plus 10, it will give you 308 Kelvin. Okay, so your T2 will be 308 Kelvin. Okay, and K1, it is not given, right? And for example, let's suppose K1 is equals to K. So what will be the K2? So here it is given that the rate of chemical reaction, it doubles. So the value for K2 will be 2K. Okay, now we know that log K2 upon K1 is equals to EA upon C. One more thing. Yes, you can by solving 2.303 and the gas constant value, you will also get this formula 19.4, right? So you can use this formula also. Just a second. Write down this formula also. Log K2 upon K1. When you substitute the value of R, gas constant, and multiply it, you will get this value. Simplest value 19.14 and T2 minus T1 upon T1 into T2. Right. So you can calculate using this formula also. So I'm using that formula, which is 19.4 into, and what's the difference between these temperature? T1, T2 minus T1, it will give you 10. Okay. And what is the just 298 T1 into T2, which is 308. Okay. Now substitute the value for K2 and K1. K2 is your 2K and K1 is your K. Okay. 10 on 298 into 308. Now this will cancels out log 2 value, right? And this will give you log 2 is 0.3 you will get. EA upon 19.4, right? And you will get 10 over 298 into 308. Now you have to calculate the value for activation energy, right? So EA will be equals to 19.4 into 0.3 into 298 into 308 over 10. Now calculate it and tell me the answer. You can use the calculator also. So by calculating this and multiplying this, you will get 91784. Okay. So your final answer will be 52702.3 in joule per mole, right? And you can write it down in kilojoule per mole, which is 52.7 kilojoule per mole. is still your activation energy. Okay, that's how you will calculate the activation energy using these formula. But for that, please remember these formula for Arrhenius equation, for activation energy, for the rate equation of all the different types of order, for first order, zero order, and all. Okay, you should remember all the formula. So this question is clear? Mira and Oksana?
Yes, ma'am.
Okay. Please remember these formula. Then only you can calculate in exam. Okay, let's move to the next topic. So it is collision theory. Before moving to the collision theory, let's discuss activation energy. What is activation energy? Let's see. Here I will discuss activation energy. Okay, so what is activation energy? It is the minimum energy that the reactant molecules is mute your mic. Okay. So activation energy, it is the minimum energy that the reactant molecules must acquire, right, in order to cross the energy barrier and to change into product, right? So the minimum energy the reactant molecules acquire in order to change into the product is known as activation energy. And how you can find the activation energy? So activation energy is basically threshold energy, thresh, threshold energy, okay, minus average energy possessed by the reactant molecule, possessed by the reactant molecule. So this is the formula for activation energy. Now here comes the question, what do you mean by threshold energy? What is threshold energy? So threshold energy, it is the maximum energy, sorry, minimum energy. Just a second. The threshold energy, it is a minimum energy, amount of energy, which is required by the reacting molecules to produce effective collision. Okay, so this is known as threshold energy. What I said, I repeat, the minimum amount of energy which are required by the reacting molecules to produce effective collision. Okay, this is known as threshold energy. And when the temperature increases, we know that the number of effective collision also increases. Effective collisions increases means the threshold energy will increase. Okay, and hence the rate of reaction also increases with a small rise in temperature, right? The rate of reaction also increases. Got it? Now,
Yes, ma'am.
here comes what are the effects of catalyst on activation energy? Effect of catalyst on activation energy. So, see, the formation of activated complex, it provides an alternate path, right? Alternate path of lower activation energy when you compare to uncatalyzed reaction, right? When you add a catalyst in a reaction, what happens? It it provide a alternate path, right? By lowering down its activation energy. Okay, so this allows a large number of reactant molecules to cross over the energy barriers in order to transform into product. Okay, what I said, when we add a catalyst in a reaction, what happens? It provide a alternate path. alternate path, right, which lowers down its activation energy, right? And this allows a number of reactant molecules to cross over the energy barrier in order to transform into product. Okay, so these are the effects of catalyst on activation energy. When you add a catalyst, the activation energy lowers down. Okay, by providing a alternate path to the reaction. Clear? Now,
Yes,
here's the last topic of this chapter, which is collision theory. Very important is collision theory. So what is collision theory? So according to collision theory, there must be a collision taking place between reactant molecules, right? But every collision is not fruitful and only a small number of collisions are effective, right? And only a small number of collisions are effective, and those collisions will bring about a chemical reaction. Okay, write it down. What I said, there must be a collision. There must be collisions taking place between reactant molecules, but every collision is not fruitful. Yeah, fruitful, right? And only a small number of collisions are effective, right? And those collisions, they bring about the chemical reaction. Okay, means, and it is based on kinetic energy of gases, right? Collision theory, it is based on the kinetic energy of gases. Means it produces greater insight into the energetic and mechanistic aspects of reaction. Okay, and what are the conditions of chemical change? So let's see what are the conditions. Yes. So a reaction occurs when the reactant molecules encounter together, right? Means when the reactant undergo effective collision with one another. Condition first is the reaction will proceed if the reactant molecules undergo effective collision. Collisions with one another. With one another. Okay? Yeah. And only those, second condition is that only those collisions are effective when which acquire a definite amount of energy, right? Only those collisions are effective which acquire a definite amount of energy. Okay? And we know that what is threshold energy? It is the minimum amount of energy which are required by the reacting molecules to produce effective collision. Okay. And as the temperature increases, what happens? When the temperature increases, the number of effective collision increases. Number of effective collision will increase. Okay, and results of that, the rate of reaction also increases. Reaction increases, right, with a small rise in temperature. So that's all for collision theory, and here the chapter completes. Okay, is there any doubt in chapter chemical kinetics?
No, ma'am.
Okay, we will do some questions. Okay, let's discuss some questions based on that. So it will be more clear to you. Basically, in your JEE exams, most of the question in this chapter came from T half or rate constant or Arrhenius type of equation. Okay, so practice those type of questions. Tomorrow is your test, right?
Yes, ma'am.
Yes.
Okay, so how many chapters are coming in your test?
Solutions, haloalkane and haloarine.
Okay, okay. Okay, so practice the previous year questions as well.
Okay, ma'am.
Okay.
Okay, write on the first question. So the question is, at 30 degrees Celsius, the half-life for the decomposition of AB2 is 200 second. Okay, this is 200 second. And it is dependent of the initial concentration of AB2. So the time required for 80% of the AB2 to decompose is. Okay, so what is given the question? So at 30 degrees Celsius, the half-life for the decomposition of AB2 is given, which is 200 seconds, right? And it is dependent on the initial concentration of AB2. So the time required for 80% of the AB2 to decompose is. Okay, so the options are 200 second, 323 second, 463 second, or 532 second, right? And the value for log is also given. Log 2 value is 0.34 and log 3 value is 0.48. Right? And log 5 value is 0.6989. Solve it and tell me the answer.
Ma'am, is it option C?
Yes, option C is correct. Done? Both of you? Done?
Yes, ma'am.
Okay, see. See, we know that for first order reaction, the T half is independent of the initial concentration, right? So the order will be 1. For this, the order will be 1. So what we will use the formula? We will use for this question is 2.303 over T log initial con the A naught minus X, right? For mark it as a equation 1. And we also know that K equals to 0.693 upon T half. Mark it as the equation 2. So from equation 1 and 2, this will be equals to T half. This will be equals to 2.303 over T log A naught upon A naught minus X. Okay. Now what is given over here is the value of T half is given. Okay. The value of T half it is given, which is 200 second. And suppose for A naught is 100 degrees, 100%. So what will be the A naught minus X? So in the question, what is given? It is 80% of the AB2, right? So 100 minus 80, you will get 20%. Okay, now substitute this value in this equation. In the equation 3, 0.693 over T half is 200, 2.303, and you have to calculate the time log 100 over 80. Okay, now you will get, so T will be 2.303 over 0.693 into log 5. Okay, and what's the log value? Log 5 value, it is 0.69 something. Okay, so when you calculate, when you put the value of log 5 and when you multiply it by this, you will get 463.92 seconds. Okay, which is approximate to 463 seconds. So your option C will be correct. Option C will be correct. Clear?
Yes, ma'am.
Yes, ma'am.
Okay, let's do the next question. So here, the rate of a reaction, it increases by 10 to the power 6 times. Okay, when a reaction is carried out, when it is carried out in presence of enzyme catalyst. Catalyst at some temperature. Okay, and the question here is determine change in activation energy. Change in activation energy. And your options are, first option is minus 6 into 2.303 RT. Option 2 is plus 6 into 2.303 RT. C option is plus 6 in RT, or D option is your minus 6 RT. And this question has been asked in JEE 2020. Okay, solve it. Tell me the answer. Okay, see, from Arrhenius equation, what we know is we know the rate constant is equals to A e to the power minus E upon RT. Okay, mark it is the first equation. And according to the question, what is given? The rate of a reaction increases by 10 to the power 6 times. Okay, so 10 to the power 6k is equals to AE minus EA dash. I'm taking this as EA dash upon RT. Okay, mark it as equation 2. Okay, please write it along with me. Now dividing equation 2 by 1. We get, okay, when you divide this, what you will get? 10 to the power 6. We are dividing 2 by 1. So we get 10 to the power 6 on the left hand side, and on the right hand side, this AA will cancel out, and you will get e to the power EA minus EA dash upon RT. Okay, now take log, taking ln over both sides. Now 10 to the power 6 is equals to ln e to the power, when you take ln, it will be minus EA upon RT. Okay, some mathematics are over here. Now just calculate it for. So when you take, so this is a log, right? So just what will you get? 6 ln 10 over here, and this will give you minus EA minus EA naught on RT. This dash over here. Now substitute the value of 6 into, and yeah, in the question, the value of ln 10 is also given, which is 2.303. 2.303. Substitute the value. Just cross multiply it. You will get AA. Yeah, when the bracket where you will open, you will get EA dash, right? EA dash will be in positive form, and you will get this in negative, minus EA. This will give you 2.303 into 6 RT. Okay, so what will be the change in activation energy? EA dash minus EA, it will be 2.303 into 6 RT. So which option is correct? So it is in positive form, means plus 6 into 2.303 RT. So option B is your correct. This is plus 6 into 2.303 RT. This is your change in activation energy. Okay, so your option B is your correct. So that type of question came in your exams, JEE exams. Based on that, we have based on the rate of reaction based on the activation energy. So these are very, very important. Just go through all the topics and practice more questions based on that. Okay. Okay, class.
Yes, ma'am.
Okay, ma'am. Yes,
Okay,
ma'am.
everything is clear. So please just practice more questions for tomorrow's